welcome to the latest edition of our Sustainability Perspectives podcast, where we hear from a range of different packaging experts to learn more about how their company tackles the sustainability challenges the industry faces. My name is Elisabeth Skoda, and today we will focus on aluminium packaging together with Constantia Flexibles. And we'll be looking at the material's carbon footprint and how to reduce it, low carbon and recycled aluminium, and we'll also take a look at developments that are in the pipeline and look to the future a little bit and much more. So with me to discuss all this is Matthias Hofinger, who is material and process expert aluminium at Constantia Flexibles. So welcome, Matthias. Thank you very much for being on the podcast today. I'm really looking forward to an interesting conversation.
Thank you, Elisabeth, for inviting me.
You're most welcome. I wanted to start with asking you what packaging applications is aluminium particularly suited to, and what are the benefits of the material?
I don't want to go too much into what applications aluminum was suited for, because that would be a very long list, but I'd like to focus on the main benefits, because essentially they define all the best suited applications. So essentially, aluminum is for you when you need perfect barrier properties, for example, against light or against moisture, or against vapor. For example, if you need a high thermal stability, quick sealing processes, or repeated recyclability of the packaging material without compromising its ability to be in direct contact with foodstuff or with medicines, then essentially aluminum is for you.
Obviously, the focus of this podcast today is also the carbon footprint of aluminium packaging. How is the carbon footprint of a particular aluminium package calculated? And what makes this such a critical metric for environmental impact?
Mm-hmm. So the CO2 footprint, or the carbon footprint of an aluminum packaging, is essentially divided or calculated by its Scope 1, Scope 2, and Scope 3 emissions. And this is calculating the direct and indirect emissions from producing this material. So indirect would, for example, be emissions allocated to energy consumption in the process, and this along the entire value chain. This is now the Scope 3 part of that. And so the beauty or the importance of the CO2 value is it gives you a certain comparability of different products in terms of their environmental impact from an emissions point of view. So, for example, if you have a material which is produced with a high amount of recycled content, or a virgin material which is produced with renewable energy, you can compare them from an emissions point of view and decide which one is better from an environmental perspective. So, in my point of view, the CO2 footprint gives you a better overview of the environmental performance of a certain product or a certain packaging material compared to, for example, the recycled content alone.
And that leads me to the question, what factors contribute to the CO2 footprint during the production of aluminum? Are there any specific stages in the process that are especially emission intensive?
Yeah, so alongside the entire production, there's one process step which stands out with the majority of the emissions which can be attributed to that process step. This is essentially where it gets the metal aluminum out of the ore bauxite. This process step is called fused salt electrolysis, and therefore you need a high amount of energy. And then depending on how you generate this energy, so for example, from renewable sources or from fossils, there is a huge influence on the entire footprint of the aluminum for it. The processes which are coming afterwards, so for example, transportation, or pre-processing like rolling, annealing, converting, usually only have a minor role in that.
And that obviously leads to the next question. What steps has the aluminium industry taken to reduce the carbon emissions associated with aluminium production? I'd imagine you probably focus a lot on that first step that you mentioned, that's particularly carbon intensive.
Yes, of course, particularly on that, but not only. So essentially in 2021, the International Aluminum Institute has published a paper, which is called its Pathway for Decarbonization. And this is in order to achieve a Paris-aligned aluminum industry footprint by 2050. And there you can see that the decarbonization of the aluminum industry is based on three different pillars. And the first one is electricity decarbonization. Then it's the reduction of direct emissions, and last but not least, recycling and resource efficiency. And a huge of different projects or tasks now feed into these different pillars. For example, we discussed fused salt electrolysis, high impact from there. So of course, renewable energy and both recycled content can improve there massively. But another project I would like to mention is on the direct emissions parts from also that process step. And this is a very successful cooperation between Alcoa and Rio Tinto, which is called ELYSIS. And essentially, they've had in the last few years had a breakthrough in a research topic, which has been worked on since, I think, over 100 years. And this is called inert anodes. So they can substitute now these carbon-based anodes, which combust during that fused salt electrolysis, by inert ones and take away the direct emissions. And I think that's a very interesting topic and a major breakthrough in the aluminum industry.
It definitely sounds like it, yeah. And obviously, aluminum is recyclable as well. And that obviously also plays a role around the carbon footprint. And could you tell us a bit more about the use of recycled aluminum in Constantia Flexible's products? And what percentage of recycled content would you say is typical, and how does it impact the carbon footprint?
So thank you for the question. As I mentioned before, with including recycled content, you have a huge ability to circumvent the emissions which come from the production from primary metal diffused salt electrolysis. So obviously we are looking into increasing the recycled share in our products. Now you have to know that the ability for aluminum to incorporate recycled content depends on some different factors. For example, which alloy do you use? Because in technical applications, we're not using pure aluminum, but we're alloying this with different other elements and partners to obtain the desired properties we want for that material. It also depends, for example, on the availability and the quality of the scrap. So naturally, we have a lot of products, a lot of different alloys we use, and also we have huge different variations in the amount of recycled content in our products. So I would say for a big part, we usually tend to state 0 because we do not get this information reliably, which means third-party certified from our suppliers. So this is a parameter which is variable. Then on the other hand side, for different products where this is in the focus and the alloy is suitable for this and the material streams are available, we do reach up to 90% or above externally certified. So huge variation.
Do you think there will be more efforts in the future to maybe boost the recycling rates or to certify it more clearly that it can be described as recycled aluminum?
Of course, so I see a lot of efforts in terms of increasing recycled content in aluminum. So there are, I would say, fundamental research topics at universities, which are called essentially crossover alloys, which are working on the task which alloys or from different alloy categories or series I can combine while still keeping my properties, my desired properties. So this is one factor. Then, of course, we are generating demand for recycled content, so we give more value that. So this is leads the way to more or new industries or corporations. And that the entire topic of low carbon alloy is getting more and more attention, I would say. So also it's now a transition process where I don't state we have a recycled content of X and we have a CO2 footprint of Y, but customers are beginning to really look into that and understand that and require really high quality data and high quality information on that. So I see upcoming and increasingly also certifications, certified calculation methods, or really also systems getting in place to get this information on a high quality level.
That sounds promising. And you mentioned low carb aluminum, and I wanted to ask you a bit more about what the definition of this actually is, and also what are the hurdles to make all aluminum that's being produced low carb. But it probably sounds easier than it is.
Yeah, for sure. So there is no one definition for low carbon out there. So sometimes it's only aluminum with a CO2 footprint which is less than average, for example, which is of course very vague. However, what we saw now in the last months is that in fast markets, they have introduced their own low carbon differential, And this is below 4 tons of CO2 equivalent emissions, scope 1 and scope 2 at ingot stage. So not, for example, at foil level or foil stock level. Because there is this definition now coming up there. The biggest challenge to increase the share of low carbon alu, I would say, is the availability essentially of renewable energy and high quality recycling material streams. So in terms of recycling, you have to know that aluminum usually in its most prominent applications, I'm talking here, for example, automotive industry or also construction, their aluminum has a very long lifetime. And being a young metal, this then results in 70% of all aluminum ever produced still being in use. So still not having reached its end of lifetime. So this limits the availability of recycled material. And so, of course, we are generating demand. So we want to decrease the CO2 footprint of our aluminum. So we have demand for recycled content. And with that development, we give value to aluminum at the end of its life. And but that, with this, we are able to realize an increase of collection and also sorting of aluminum at the end of its life, which you need to achieve a high quality of that aluminum scrap. And this is really what we need to do, essentially increase our renewable energy sources and really value aluminum at the end of its life to be able to include it into a new product and give it a new life.
That makes a lot of sense, yes. And I wanted to wrap up our conversation by asking you about the future and looking to the future of aluminum as a packaging material. What developments do you foresee in the coming months and years?
So for aluminum packaging in particular, I would say that the focus is definitely on recycling. So for example, what I already see or what we already do is in the past 10 years, we have seen that as alloy specifications have been narrowed and narrowed down. So essentially, which amount of different elements can be incorporated in a certain aluminum alloy or product, I would say. And there's now this trend has shifted to the opposite. So now we are again opening up these specifications to be able to now incorporate higher amounts of recycled content whilst keeping the high quality and also the performance on the same level. On the other hand side, we see a focus on the collection and the processing. So essentially the sorting and pyrolysis processes to be able to achieve high quality aluminum scrap, which you need to incorporate again to have a high recycled content. We see a trend of PVC or to get PVC out of packaging applications to polyvinyl chloride. Ink contains chlorine, of course, and this can generate dangerous waste gas, essentially lead to corrosion in your machines. So we are developing chlorine-free applications, but also, of course, monomaterial solutions. So this is not only true for mono PE or mono PP, but also for mono aluminum applications to be able to really generate high recycling rates of applications out there, which are easy to collect, easy to sort, and incorporate into a new aluminum packaging application.
Great, that makes a lot of sense. And we look forward to watching this space and seeing how the industry develops in the coming years. So that brings us to the end of today's podcast. Thank you very much for being here with me today, Matthias, and sharing your insights with our listeners.
Yeah, thank you too for the very interesting discussion.
Thank you. And as always, a quick reminder for all our podcast listeners, make sure you subscribe so you don't miss any of the latest episodes. Thanks very much. Goodbye.